Запись идет.
Good day. I am Yuliy Cheshkin from Moscow, Ishlinsky Institute of Problem and Mechanics, and I am happy to present you some observation and calculations of flows, dynamics, and structure. Composition of talk is standard, some images of flows, introduction of physical quantities, basic system of equation, theory of angular perturbation, and definition of ligaments, some new examples, conclusion, and thank you very much for giving me a chance to present this talk. The history started from the paper, better say, to book of René Descartes, Principia Philosophia, where he put the sketch of starry sky. And this sketch is very similar to what can be observed by Hubble telescope. This is flash of Monoceros, and you see the image after several years, and the distance of this image is several light years. So you see giant vortex-like structure and filaments. If we go to the sun scale, we will see that photosphere of sun is covered by cells, and cells are separated by some interfaces. The size of these interfaces transcend sizes several kilometers. So inside the interfaces, one can see in space some free filaments. And atmosphere also stratified. The buoyancy period stably decrease with height. And sharp interfaces separate more homogeneous layers. And you see the brilliant stratification of atmosphere in these lenticularis clouds. This evolution can be observed, the revolution can be observed several hours. The same shape has the surface of Marine Sea. The wave crests are well known, less known what is it, what are the stripes. And the stripes we can see not only in sea, but also near the obstacle, upstream influence, wavy pattern, wake, and what is it. If we look at the theory of state of atmosphere ocean, we will see that both media are stratified, and stratification scale can be similar. Main buoyancy period about 10 minutes, so it is weakly stratified fluids. In laboratory, strongly stratified, and a lot of other scales of different size, even very small, and some of them are similar, and some of them are different. And besides the certification, there are homogeneous fluids. Potentially homogeneous certification is very weak. We cannot taste it, but it manifests itself. And actually, homogeneous fluids, it is modern classical theory, but these fluids cannot exist in the environment, cannot exist in the nature. In the laboratory, if we fill the tank with stratified liquid, fresh water above, salty water below, and look through very sensitive and well-resolution Schlieren instrument, we will see the wake pass slowly moving sphere. The wake is a wavy set of touch internal waves, another set of waves inside the vortex, and besides the waves, the electrolytic precipitation method shows that this wake is filled with vortex columns with vertical X. But in homogeneous fluids, we have vortex rings past the sphere, vortex rings, this circular center. With increasing of velocity, the sharpness of interfaces increases, and it's separated on different filaments, and vortex structures also change. Smooth vortex bubble at low velocities is changed by a sequence of butterfly vortices or vortex rings, and this vortex is a source of internal waves. More complex flow pattern past the drop, from the drop falling into fluid at rest. Everybody knows that there are some spikes, but besides the spikes, the dye drop form a vertical structure in the crown, and with time the structure is transformed into cellular structure with well-organized layers. And this vertical structure is transformed into horizontal structure in the wavy field. And the surface of the splash, for example, is also not smooth. It's covered by capillary waves and some roughness, very small size. and the brilliant symmetric flow on later stages. So what is status of modern fluid mechanics? It was presented by Srinivasan in this talk, and he subject that the fluid mechanics met some difficulties in the case of money and faculty position, and the turbulence theory are still unsolved, and the fluid mechanics is a subject in itself, a self-referent and inbred, and the community awaits some new ideas and new results. The basis on this theory is Stokes equations, and Stokes equation was written, it is supposed, for homogeneous fluids. But what is real life? The real life need to come back to the foundation of logic and look on the principles, look on the demands of Maxwell selection of right physical quantities, and recommendation of Mendeleev to select measurable physical quantities which can be measured with estimation of accuracy. So conventional logic, Aristotle contained identity, non-contradictions, excluded middle position. Leibniz supplemented substitutions sufficient, minimal efficiency, also causality and completeness was added by physics, and now the variety of different models which are not related with each other in fluid mechanics need to introduce the condition of definition, meaningfulness, the definition of subject studied, and its description in different categories. The basic parameter of the fluid in this approximation is density, which was measured and by Mendeleev for gases and for fluid solutions, and a numerous number of physicists later. And Gibbs, who introduced the Gibbs potential, and shows that density is variables of derivatives of the Gibbs potential. From international results of International Association for Properties of Water and Steams was that the main parameter is Gibbs potential, and Gibbs potential is not uniformly distributed in the media. Inside the medium, all media consist really from cells, from different associates, which are complexes, cluster, bands, voids, and so on. And every associates contain its envelope, and any envelope contains this term with local analogous surface tensions. So when the cell disappears, the energy is transformed into heat and mechanical motions on the smallest scales. And when the cell is formed, the energy is kept from taken from the mechanical motion energy and heat. So the permanent restriction, permanent redistribution of cells contains some kind of internal motion which provides no friction for fluid flows. So the mechanism of energy transport, besides the well-known translation with flows, with waves and vortices, with dissipation, need to take into account the conversion of potential surface energy. And the sun surface is a brilliant visual image of the any real fluid, real gas. So how manifests itself the transformation of vortices? For example, when drop fall into the fluid, it follows the cavity, the crown, and spikes producing these small droplets. But if you look in another illumination, you will see that the low bottom of enemy is not smooth. It consists from several small spikes which push this bottom and form very complex layer with complex structure. Another mechanism of filament formation connected with the collection of fluids moving along these trickles and collecting in nodes of the net. And below the nodes, some small vortices formed. These vortices transformed into vortex loops. So to describe the flow structure, it is necessary to combine all well-known results, which was received by Galilei, Descartes, Newton, Leibniz, Bernoulli, Euler, Lambert, Fourier, Navier, Stokes, Maxwell, Fick, Mendeleev, and Gibbs. And this was done by Mendeleev, this was done by Landau and Lifshitz, who in 1944 wrote a general system consistent from continuity equation of substance conservation, momentum, and energy transport, and the equation for density is the equation of state. And now the equation of state for potential Gibbs is added to take into account transformation of energy into potential in active form and back. For practical calculation, this system is simplified and rewrote for physical variables like temperature, concentration, and velocity. And this system is very good. It corresponds to basic physical principles because the trait contains the 10 Galilean group of point transformation. And this group means that the law of conservation of energy, momentum, and vorticity is saved. And of course, Galilean's transformation is satisfied. So this system corresponds to basic principle of physics. Other systems which are well distributed in fluid mechanics doesn't correspond. For example, Navier-Stokes equation is over determined, and it contains right generators of sheets, conserving energy and momentum, but extended Galilean principle of relativity, accelerated system also can be used, and additional discussional group, which give a room for different theories, like series of boundary layers. To solve this system, we can note that there are small coefficients in terms with highest derivatives, so the system can be treated by the series of singular perturbation, and complete solutions can be constructed using both kind of expanding into series, constructing regular series and constructing singular series, as was shown by Professor Naifeh. So if we substitute the Fourier expansion into equation, we receive the dispatching relation in very complex form. And for example, for surface waves in ideal fluids, in viscous fluids, it transforms in the equation of fifth order, and physics is certified to the same fifth order for 2D case. And this also equation is singularly disturbed. So if we save the variable density, we have a resolved system. If we have homogeneous density, we have no resolved system, or the result was problem of small dimension. Reduced set of equation was solved for a number of examples. For example, flow induced by diffusion. Flow induced by diffusion push the asymmetric body, sphere is fixed, body is moved, slow velocity several centimeters per hour, but it is stable, and this is a real structure. Internal wave beams are covered by envelopes, and envelopes can be manifested in Schlieren images. And when two beams intersected, there goes, and the condition of free transportation is satisfied, but for large amplitude wave produce 5 interfaces. These interfaces can interact and form a new source of waves, pass through oscillating body. Propagation waves inside the fluid with less frequency, buoyancy frequency is forbidden, and it reflected, and this calculation made in 1998 was supported by experiment in 2012. So, and the last illustration is the singular vortex. Normal vortex propagate and increases number. Singular vortex is formed when the drop of alcohol fall into the fluid. Propagate, it doesn't change its sizes. So advantage observable physical quantity used, it can be calculated and observed, And there are a lot of examples in laboratory and in vent tunnel and in water tank. And waves are ligaments are inseparable component of periodic flows. Ligaments are thin filaments, and vortexes also share components with pieces of ligaments. So the ligaments also are observed in the flow, and Stokes equation really equivalent to some algebraic geometrical transformation. And fluid flow is a flux of momentum, energy, and density. Fundamental equation is complete. Ligaments exist, and regular and singular vortexes are long or compact, and new instrumental protocol must be invented. Thank you very much for your kind attention.